I am very happy and jubilant to interact with you again. Uh, Hopefully and prayerfully wishing to interact with you on offline mode quite shortly. So let us all pray together. Right. So today in this video we are going to see part 7. Okay. Electrochemical cell. And this video is devoted especially to finding out cell potential or EMF. Cell potential or EMF, both are same. Here I have given you the definition, EMF definition. Actually, electromotive force, cell potential. Before going to know the definition, I want to tell you one thing. Actually, the EMF is generated or electrons flow from one compartment to another compartment, that is from anode to cathode, electrons travel. Remember, what causes or what is the need for electrons to travel from one end to another end? There exists some gradient. You know what is a gradient? One should be high, another one should be low. You know very well that rivers originate from mountains and they go and reach towards sea. What is the reason now? Because you have the gradient, a sloping gradient. Okay, that is why we measure the height based on the sea level. Correct? If there is no gradient, you cannot see flow of water, flow of river. No, impossible. So mountains are elevated. Sea they are laying down. That is because of the gradient, water flows. Similarly, electrons flow from one one compartment to another compartment. The basic reason is because of there is some gradient. Okay, ma, you know very well that the gradient is always there. In anode compartment, we place a highly reactive metal. In cathode compartment, we place less reactive metals. Automatically, there exists some gradient. So, highly positive metals or highly electropositive metals will lose electron and that will travel towards less electropositive side. So, this is what we call as gradient. Okay. Next, last class, sir, in the previous video, I spoke to you about potential. What is a potential? A trigger kind of feeling. I introduce a rod into a solution, automatically potential is developed. See, when electrons are lost, that is oxidation potential. When electrons are gained, then we call it as reduction potential. Correct? If electrons are lost, oxidation potential. Electrons are gained in a reduction potential. Okay, actually what is the meaning of potential that we are going to see now? Okay, potential means a kind of a trigger that arise because of loss of electron, because of gain of electron. The potential developed because of loss of electron is called oxidation potential. The potential developed because of gain of electron is called reduction potential. Remember, oxidation potential and reduction potential for particular metal, the numerical value will be same, sign will be different. For example, I tell you, we come to it later. This EMF or cell potential is given by the symbol E. Okay, so this is the E. E refers to EMF or cell potential, and we have one more term called E naught. Some people call it as E star. This is standard EMF. This is ordinary EMF. What is standard EMF? If the experiment, if the electrochemical cell is constituted and carried out under standard condition. What are standard condition? Pressure is 1 atmosphere, atmospheric pressure. And then the solutions placed inside the container, both in anode compartment and cathode compartment, the solution concentration must be 1 molar. The concentration of the solution must be 1 molar. Temperature 25 degrees Celsius. If the EMF is measured under that conditions, then we call it as standard EMF. If the EMF is measured under 0.1 molar, see 0.1 molar is not standard solution. Suppose EMF of the cell measured using non-standard concentration, it means not 1 molar, then that is ordinary EMF. Okay, that is ordinary EMF, this is standard EMF, right? What I would like to say now, what exactly the difference between reduction potential and oxidation potential for a particular metal? Numerical value will be same, sign will be different. That I am going to tell you now. E naught, Zn2 plus bar Zn. Zn2 plus to Zn, Zn2 plus to Zn reduction. Plus 2 to, this symbol is. So what is the value? Minus 0.76 volt. How would you pronounce this canal? This is called reduction potential. Reduction potential. Correct? Then I would like to find out the value of E naught Zn bar Zn2 plus. Now how would you call this? Zinc becomes Zn2 plus. 0 to plus 2. This is oxidation potential. Can you tell me the value? Reduction potential is minus 0.76. Oxidation potential plus 0.76 volt. What did I say? Numerically the value is same. Sign is different. This kind of question will be asked in board exam. Correct? You are given reduction potential of so and so metal is minus 0.42 volt. What is its oxidation potential? You are not supposed to blink. If the reduction potential is minus 0.42 volt now, oxidation potential is plus 0.42 volt. That's all. Now you see the second example, nickel 2 plus bar nickel, E naught standard. E naught, nickel 2 plus bar nickel. What is nickel 2 plus? Plus 2 to 0, which is minus 0.25. Let us find out E naught of nickel bar nickel 2 plus. That is minus 0.25. This is what? Plus 0.25 volt. How easy it is? Correct? One more example. What is the one more example now? Here I have given you reduction potential of copper. Reduction potential of copper. What is that? Plus 0.34 volt. Shall we find out oxidation potential? E naught Cu bar Cu2 plus, which is minus 0.34 volt. What I would like to say is, if oxidation potential is positive value, now reduction potential will be negative, number will be same, sign will be different. Okay. Come back to our topic now. At anode, that is anode compartment, left and right hand side cathode compartment. At anode compartment, what potential will be developed? Oxidation potential, because there oxidation takes place. At cathode, what is taking place? Reduction. So one side you have oxidation, another side you have reduction. We call that as oxidation potential, and this side as what? Reduction potential. Some teachers, some trainers, they call it as anode half cell potential, cathode half cell potential. Simply speaking, half cell potential. What half cell? Anode. Anode half cell na generally oxidation. Cathode half cell means what? Reduction. This is the introduction. Okay. Now you can really know what is the reason for transfer of electron from one end to another end, flow of current from this side to that side. Remember, if electrons flow from left to right, currents flow in opposite direction, right? When electrons will not flow, sarcastically let us say, when there is no current flow, electron will not flow. When current will not flow, when there is no electron flow, current will not flow. Actually, both answers are same. Okay. Now, let us say a unified answer. Electrons will not flow, current will not flow, provided if the difference in electrode potential of anode compartment and cathode compartment, if it is same, electron will never migrate, current will not flow. That is very important, mark. See, I want to constitute an electrochemical cell. I should select anode compartment with highly electropositive metal dipped in its salt solution. I should select cathode compartment with a less electropositive metal dipped in the same solution. Correct? I am not supposed to take almost equal valued metals. In that case, there is no potential gradient, no gradient. So the electron will not come this side, current will not flow that side. So, if electron is flowing from one end to another end, current is flowing from another end to another end, that is from anode to cathode, cathode to anode, we come to a conclusion that there exists some difference in potential. The difference in potential is known as what? EMF, electromotive force. And the electron is motivated to flow from one end to another end because of what? EMF. If there is no difference, for example, why do you go to school? Why do you come to institute? You have some gradient. Okay, well, you lack something at school or you lack something somewhere else. In order to fulfill your coming, imagine all of you are extraordinarily knowledgeable in physics, chemistry, math, biology, English, etc., etc. Then you have no necessity to go anywhere. Correct? We go to a particular place because of the gradient, because of the difference. Okay, well, one is somehow higher, another end is down end. That is why we go. Otherwise not. If you are really fulfilled in all aspects, there is no necessity for work. Correct? I am saying philosophically. Very important definition. What is now come to the definition? What is EMF of the cell? The potential difference between the two electrodes. The potential difference between anode of cell and cathode of the cell when neither no current or negligible current is allowed to flow in the circuit. Correct? What is the potential difference? It is because of the potential difference. It is because of the potential difference the current is flowing. Correct? If there is no potential difference 0 now, electron will not flow, current will not flow. Correct? That difference is called what? EMF. Okay. Next important point, how you are going to determine EMF of the cell? Some of the students will say, sir, sum up EMF of sum up electrode potential of anode of cell and cathode of cell. Very good. Correct? We agree. Okay, but there we have one problem. What problem now? If you sum up, you get the difference. There exists one problem. What is the problem now? If you do with respect to anode, you measure oxidation potential. When you measure with the cathode, that is cathode compartment, we talk about reduction potential. Listen to me very carefully. IUPAC recommends the uniformity in both the cases. See, one case I am using oxidation potential, other case I am using reduction potential. What IUPAC suggests? IUPAC recently it unified. IUPAC recommends the usage of only reduction potential. Everywhere is the problem. Correct? IUPAC recommends the use of only reduction potential, not oxidation potential. So it may be a contradictory. Sir, for anode of cell, you are writing reduction potential now. Actually, that is oxidation potential. This is reduction potential. When you sum up, you get the EMF. But IUPAC unifies the concept. It says, in the previous case we are adding. Now, recent version, how you are going to determine EMF of the cell? Now, EMF of the cell, EMF of off-cell potential of cathode, off-cell potential of anode. Correct? Cathode minus anode. What is cathode? Right hand side. So, EMF off-cell potential of right hand side, off-cell potential of left hand side. I hope you understand. Okay? Cathode minus anode. Many people they think they do it as what is that? CA, cathode. EMF of cathode minus EMF of anode. EMF of right hand side minus EMF of left hand side. Now, what is the last one? That is why I wrote in the red color. Reduction potential of cathode minus reduction potential of anode. This many students understand, sir. Cathode reduction takes place. Why you are writing reduction potential of anode? Actually, anode what is taking place? Oxidation. But we take only reduction potential. How would you obtain reduction potential when sign is converted? So you will be given oxidation potential. You make the sign ulta, you get what? Reduction potential. So these three formulae should be memorized by you. What is EMF of the cell? EMF of the cell. EMF of cathode minus EMF of anode. E right minus E left. And then next one, reduction potential of cathode minus reduction potential of what? Anode. Standard EMF of the cell. Standard EMF of cathode minus what? Anode. Are you able to understand? Very important. Actually, after doing this, you just take your this book, your NCERT textbook. I will show the page where the reduction potential given. Again, I am telling you, when you want to find out EMF of the cell, we have to take only reduction potential. Correct? Even if you are given oxidation potential, make it ulta, reduction potential, right? Now, I would like to find out EMF of Daniel cell. Okay, right. First of all, what is Daniel cell? Let us find out EMF of what? Daniel cell. Okay, shall we depict Daniel cell? Zn bar Zn2 plus salt bridge Cu2 plus bar Cu. What is our intention? To predict standard EMF of Daniel cell. First formula, E naught of the cell. This is cathode, this is anode. So, reduction potential of cathode minus reduction potential of what? Anode. How would you write that? E naught of reduction potential Cu2 plus to Cu. So you write Cu2 plus bar Cu minus E naught of, here we write Zn Zn2 plus, that is notation. But here oxidation takes place. But we have to write only reduction potential. Then what you write? E naught of Zn2 plus bar what ma? Zn. Previously, few minutes back, I wrote those values ma. You refer. What is the reduction potential of copper? 0.34 volt minus reduction potential of zinc minus 0.76 volt. Now 0.34 volt plus 0.76 volt. When you sum up, you get how much ma? 0.76 plus 0.34 plus 1.1 volt. This is the EMF of Daniel cell that we are going to write in the corner. E naught of the cell is equal to plus 1.1 volt. What did I say earlier, Kana? I said earlier that after writing the cell convention, at the end we should write the EMF. Only here students get confusion, sir. Here Zn bar Zn2 plus is given. You are writing Zn2 plus bar Zn. This is cell convention. I do agree that here oxidation takes place, but IUPAC recommends us to make use of only reduction potential. So this is reduction potential. This is reduction potential. This value will be given. And one more thing, ma. Under what condition a cell is feasible? Feasible. Feasible na possible. Okay, ba? You will be given a cell. After that, after being given with a cell, you will be asked to predict whether the cell is feasible or not. Whether the cell will function or not. Na. What you have to write? You should write the cell notation. After writing the cell notation, you have to find out EMF of the cell using the formula right minus left. If the final value is positive, if EMF of the cell is positive, then the cell is feasible. If the EMF is not positive, the cell is not feasible, infeasible. Now you see Daniel cell EMF is positive. Okay, very important one. We are going to do a couple of reactions. We learned about EMF of the cell. I have given you 3 different cells and we are going to find out EMF. Okay. If you are having NCERT textbook, in electrochemistry lesson, you can see this table. This is reduction potential table. While working out the sums, you can refer to the table. In board examination, in the instruction column itself, you will be given the EMF values. Here, all the potentials are reduction potentials only. I am not telling you the page number because you have 2 different versions. New edition, old edition. Page numbers may differ, but this is reduction potentials, right? Now, what I am going to say now, very important. I have to find out EMF of this cell, this one, this one. Can you name this cell copper zinc cell? Exactly ulta of Daniel. Definitely, you can come to a conclusion that this cell is not feasible because Daniel cell we are making it ulta. Anode is made cathode is made anode. Without working out, I can say the EMF of the cell minus 1.1 volt. Let us check. Cu bar Cu2 plus, salt bridge, Zn bar Zn2 plus. Actually, Zn not Zn bar Zn2 plus. I wrote wrongly. I am very sorry. This is Zn2 plus bar Zn. Correct. EMF of the cell. Cathode minus anode. This is reduction potential of cathode minus reduction potential of anode. This is oxidation, but you have to write reduction potential. So, E naught of Zn2 plus bar Zn minus E naught of Cu2 plus bar Cu. This is minus 0.76 volt minus plus 0.34 volt. Minus or minus plus. So, minus 1.1 volt. Not feasible. The cell is not feasible. Okay. What type of questions can be asked based on this? Will it be advisable to store zinc sulfate solution in copper container? Yes. Yes. What is the reason? Zinc sulfate solution. Remember copper container and then what? Zinc sulfate. Can you store? Easily you can store. What is the reason? First reason, copper is less electropositive. It cannot displace. For that 1 mark will be given. You have to prove. So we are proving copper bar copper 2 plus salt bridge Zn2 plus bar Zn. In the previous video I told you for which type of questions this answer should be given now. Zinc sulfate solution can be stored in copper container. Why? The answer. Zinc sulfate solution can be stirred using copper rod. The answer is this. First, copper is less electropositive. For that, half mark or 1 mark will be given. Then you have to prove via EMF. Look, EMF. EMF is minus 1.1 volt. Negative cell is not feasible. Hence, you can store. Okay. This is called a copper silver cell. On seeing this itself, we can predict the cell reaction is feasible because copper is more electropositive than silver. Actually, copper 2 plus Ag. What is EMF of the cell? E naught of the cell. Cathode minus anode. E naught of Ag plus bar Ag minus E naught of Cu2 plus bar Cu. Ag plus bar Ag 0.80 volt minus this is 0.34 volt. When you subtract, you get 0.46 volt. The cell is feasible. Cell is feasible. So, here, what type of questions can be asked? First, is it advisable to store silver nitrate solution in copper container? Copper, silver nitrate, AgNO3. Based on 10th CBSE, you can predict it. Copper is more electropositive than silver. Not possible to store. Or is it advisable to stir the solution of silver nitrate using copper rod? No, not. EMF wise you have to prove the copper 2 plus Ag plus Ag. EMF is 0.46 volt. EMF is positive, the cell is feasible. Hence it is not advisable to stir silver nitrate solution using what rod? Copper rod. Okay, that is very important. Next one, this one. This is zinc silver cell. Zinc silver cell. Surely this is feasible because zinc is more electropositive than silver. Zn bar Zn2 plus alternate Ag plus bar Ag. E naught of the cell. E naught of Ag plus bar Ag minus E naught of Zn2 plus bar Zn. This is 0.80 volt minus of minus 0.76 volt. Correct? So minus of minus plus 0.80 volt plus 0.76 volt plus 1.56 volt. The EMF is positive, the cell is feasible. Here, what type of questions will be asked, ma'am? Zinc, silver nitrate. It is not advisable to store silver nitrate solution in an alloy made up of zinc. No. It is not advisable to stir silver nitrate solution using what rod? Zinc rod. Because EMF is positive, the cell reaction will occur. So this is how you have to tell. Correct? In the previous video I spoke to you. Displacement reaction takes place, redox reaction takes place. For all those things, you will be awarded only 1 mark. Based on EMF, you have to prove. One more thing I want to tell you. If you want to prove based on EMF now, you need to have extraordinary knowledge of which is anode and which is cathode. That cannot be taught by any trainer in the examination. You have to practice yourself. Okay. Persistence practice will make you a better performer. Okay. In electrochemistry, you will be given questions like this. Actually, I didn't create a question here. Let me dictate you orally. This is the cell, zinc nickel cell. Zinc nickel cell. You have been asked 3 questions. First, predict whether the cell is feasible or not. If so, write the anode of cell reaction, cathode of cell reaction, overall reaction. Altogether 3 marks. I again repeat. Predict the feasibility of the cell. Write anode of cell reaction, cathode of cell reaction, overall reaction. First let us say the feasibility. This is cathode, this is anode. E naught of the cell, E naught of nickel 2 plus bar nickel minus E naught of Zn2 plus bar Zn. Nickel 2 plus bar nickel is minus 0.25 volt. Minus of minus 0.76 volt. Minus of minus plus 0.76 volt minus 0.25 volt. This is 0. Plus 0.51 volt. So the cell is feasible. FEASIBLE. The cell is feasible. Yes, the cell is feasible. You have been asked to write anode of cell reaction, cathode of cell reaction, overall reaction. First, anode of cell reaction. Zn becomes Zn2 plus. So zinc solid will lose 2 electrons to give Zn2 plus aqueous. What is cathode of cell reaction? Nickel 2 plus becomes nickel. So nickel 2 plus aqueous gains the 2 electrons to give you nickel solid. Add this one and that one. When you add Zn plus nickel 2 plus, okay, 2 electron gets cancelled. So Zn2 plus aqueous and nickel solid. This is the overall reaction. What do you understand this? We understand that zinc displaces nickel 2 plus from its salt solution. Hence, it is not advisable to store any nickel salts in zinc container. Nickel salts should not be stirred using zinc rod. Okay, Mama? So this is the important discussion of predicting EMF of the cell. Based on that, we studied about the feasibility and infeasibility, etc. What is going to be our next move? This is standard EMF, ma'am. We want to know the EMF of the cell if it is operating under non-standard condition. Actually, we all did this for 1 molar concentration. If the concentration is not 1 molar, then how you are going to predict the EMF of the cell? That one, and then equilibrium constant and the Gibbs free energy. This will constitute another segment. After that, we have 5 marks problems now, based on one equation. That about that I am not going to talk in this video. After that, batteries, fuel cells. So I think 1 or 2 videos needed to complete this electrochemical cell, and finally we sign off with the conductivity. I hope you are all enjoying this electrochemical cells and electrochemistry. Keep enjoying, keep studying. I will be meeting you with the fresh and new videos of the same topic again. Thank you so much.